Hello, welcome back. So now in this video, we are going to solve some example based on moment. So first numerical example is based on the moment of force, calculating moment of forces. So there are some diagram. So in this case, it says that for each case illustrated in figure, determine the moment of forces about point O. So first we are taking the case one. So in the case one, you can see there is a rod which is connecting with this point O, and there is a force acting on the free end. Okay. So now the line of action of this force is like this, and this force will try to rotate about point O. So we are supposed to find out the moment, magnitude of the moment about point O, which is because of this force. So the perpendicular distance from point O to the force line of action of the force is 2 meter. So in this case, moment about point O will be 100 Newton multiplied by 2 meter. So now one more thing we will see that the rotation of this body is like this, and this rotation is actually anti-clockwise. So in that case, no, actually clockwise. So in this case, the moment will be 100 into 2. So it becomes 200 Newton meter. So that becomes the solution of the first case. Similarly, we will be having second case. So in this case also, we have to find out moment. So now in this case, you can see the direction of the force is right to left, which is 50 Newton, and sense is leftward. Now the line of action of the force is shown by this dot line. So this is the line of action. So we will always see the line of action, and we will measure the perpendicular distance with reference to the line of action. So the perpendicular distance of point O with reference to the line of action will be this one, this time, because the sense of this force is leftward. In this case, the sense of the force was downward. Okay, so this is the line of action. So in this case, the moment will be again clockwise. So you can see this in the image, in the shadow, the rotation is also shown, and it is rotating like this because of the effect of this force. So in this case, moment O will be 50 into the perpendicular distance, which is 0.75. So that is the case in this time. So it would be, I think, 37.5 Newton meter. Similarly, if we have another case, so in this case, there is a vertical rod and force is again 7 kilonewton, and it is in the leftward direction. So the line of action of the force is this one. So we will always see where is the line of action, and we will always measure the perpendicular distance with reference to the line of action. So line of action is this one, and the body is rotating about point O. So the distance of line of action to the point O, this distance is 3 meter. So in this case, moment O about O will be 7 into the perpendicular distance, so which is 3 meter. So this time the moment will be 21 kilonewton meter. So that becomes the moment. So this is how we are going to solve the moment of force, I mean solve problem for the moment of forces. Similarly, we will solve now the second example, which is based on the resultant moment. So resultant moment we will be calculating when there are a lot of forces acting on the body. So in that case, how do we find out resultant moment? That we will see. So now this is the case. There is again a rod and there are four forces acting on this rod. First force is of 50 Newton, which is acting 2 meter from the point O. Similarly, the second force is of 60 Newton. And now you can see the 60 Newton force line of action is passing along the point O, which means there is no perpendicular distance between the line of action and point O. So in that case, the distance or the moment created by this force will be zero, because there is zero distance. Or we can say that 60 Newton force is basically the concurrent force. Then there are two forces. One is of 20 Newton. So perpendicular distance from this point is this one. So the perpendicular distance of 20 Newton force will be this one. And the second force is 40 Newton. It is downward force, and line of action of this force is this one. And perpendicular distance of this force from point O will be this one, which is 3 meter. Sorry, actually 3 meter is, one second. This 3 meter is actually this inclined part. So we are supposed to find out this distance and also this distance, which is say X. So now you can see there is a small triangular, right triangular formation. So I'm making this here. So it is looking like this. So we know this is 3 meter, and we are supposed to find out this one and this one. And the angle is given here as 30 degree. So if we consider this distance as X, so X would be 3 sine 30. And if we consider this distance as Y, so in that case, Y would be 3 cos 30. Okay. So now I would write here that the distance between 20 Newton line of action and point O would be 3 sine 30 degree. Similarly, this distance would be 3 cos 30 degree. Okay, so that is what it is all about. So now we know that the distance between the line of action of 40 Newton force and point O is 4 plus 3 cos 30 degree. Okay, and distance between 20 Newton force and the line of action, 20 Newton line of action and point O. So this distance is 3 sine 30. Okay, and line of action of 50 Newton force and point O, the distance between them is 2 meter. Similarly, there is a zero distance from this 60 Newton force and point O, so there will be zero moment because of that. So to find out the resultant moment about O, we can say that summation of F into D, which means summation of all the moment of forces, algebraic sum of all the moment of forces will be equivalent to the resultant moment. So we will consider the first moment force. So first moment of force is 50 Newton multiplied by the 2. So the moment created by this force about point O will be like this. So which is clockwise. So we are taking this as a positive. Similarly, moment created by this force will be 0. So we will write here as 60 multiplied by 0. Similarly, the moment created by this force, it would be like this. You can see the direction is rightward, and if we take this force here also in the same line of action, you can see this force is actually trying to rotate anti-clockwise. So we will take minus 20 into 3 sine 30 degree. Similarly, the next force, which is 40, which is downward. So this downward force we will take, this downward force will be rotating about O, and it would be clockwise about point O. So it would be plus 40 into distance is 4 plus 3 cos 30. So 4 plus 3 cos 30. So that is the algebraic sum. So now we will calculate it, and the resultant of this force is, so it would be 334 Newton meter. So you can see the value is positive. So positive means the moment, resultant moment would be clockwise. So now I would say that the moment of the resultant moment would be like this, and the magnitude of this resultant moment would be 334 Newton meter. Okay. So we will continue our discussion in the next part. Thank you.